Okay, so today is part 2 of the review unit for solving for x-intercepts of a quadratic trinomial. So it could also be rephrased as find the solution set of a quadratic trinomial. Either way, what x values make this whole thing become 0? So my tip is to print out that little template that I sent you. In other words, pages 2 and 3, what I usually did was I double-sided printed them and I handed that worksheet out in class so that the quadratic formula could be easier to write, because I know it takes forever to write. So feel free on the exam itself to use this fill-in-the-blank model for all the problems if you prefer the quadratic formula. So mix and match if you like to factor some and do quadratic formula for some or even all of the exam, feel free. That being said, when a is not equal to 1, like in this problem, when a is equal to 2 in this case, I kind of like the quadratic formula, because even though factoring can be done, it takes a while and you don't even know if it can be factored. So a is 2, b is 11, and c is 12. Well, I could factor, multiply to ac and add to b, and then split the middle term and then factor by rectangle, but I kind of like the quadratic formula in this case. In this case, we're going to solve by plugging in negative b plus or minus the square root of b squared minus 4ac, all that over 2a. So in this problem, the b is 11, plus or minus the square root of b, which is 11 squared, minus 4 times a, in this case 2, times c, which is 12. All that over 2 times a, the a itself is 2. So now let's clean this up. So we've got negative 11, or just negative 11. Well, that was easy. Plus or minus the square root of 11 squared. Well, that is a 121. Negative 4 times 2 times 12. So negative 4 times 2 would be negative 8. But just to be thorough, negative 4 times 2 times 12. That'd be negative 96. So 121 minus 96 over 2 times 2, which is 4. So now we've got negative 11 plus or minus the square root of 121 minus 96. That'd be 25, okay? So we've got the square root of 25 over 4. So now I'm going to pay attention to this inside. Specifically, the discriminant b squared minus 4ac is positive. So if the square root if the discriminant is positive, that means there's going to be 2 real solutions. So there will be an x1 and an x2. Okay, so now we've got negative 11 plus or minus the square root of 25 over 4. Well, now we know what the square root of 25 is. That's going to be 5. So we've got negative 11 plus or minus 5 over 4. So that's where the x1 and the x2 come from. So now I'm going to write x1 is equal to negative 11 plus 5 over 4. The other one, x2, is going to be negative 11 minus 5 over 4. So let's start with the left side, x1. So x1 is negative 11 plus 5. That's going to be negative 6 over 4. You could reduce this to make this negative 3 over 2. I personally like a decimal if possible. So negative 6 divided by 4, that's going to be negative 1.5. So that is one of these solutions. Okay. Or x2, which is negative 11 minus 5 over 4. So negative 11 minus 5 is going to be negative 16 over 4. And negative 16 divided by positive 4 is negative 4. So the two solutions that make this equation, 2x squared plus 11x plus 12 equals 0, the two solutions are x can be negative 1.5 or x can be negative 4, and that will work. You can plug it in and check your result. All right, moving on to problem number 2. Find the solution set for 10x squared minus 9x plus 2. Okay, so once again, we could use quadratic formula, or we can figure out what multiplies to AC and adds to B, and then split the middle term, and then factor by rectangle. But personally, if something's going to take forever, I'd like it for it to be the sure shot of the discriminant test. So A equals 10, B equals negative 9, and C equals 2. So now that we've got our A, B, and C, let's plug in the quadratic formula. Negative B plus or minus the square root of B squared minus 4AC over 2A. So we've got negative B. Well, B is negative 9. Plus or minus the square root of B squared, which in this case is negative 9 as well, minus 4 times A, which is 10, times C, which is 2. All that over 2 times A is 10. So now let's clean this up. Negative 9, well, that's a positive, so that's positive 9. Plus or minus the square root of negative 9 quantity squared. Negative 9 quantity squared is 81. All right, and then negative 4 times 10 times 2. Well, negative 4 times 10 is negative 40. And then negative 40 times 2 would be negative 80. So that's 81 minus 80 over 2 times 10, which is 20. And now let's clean up this radical on the inside. So now we've got 9 plus or minus the square root of 1 over 20, because 81 minus 80 is 1. So now, once again, the discriminant on the inside. I make a little note to myself because that helps me out. The discriminant, b squared minus 4ac, is technically positive 1. So because b squared minus 4ac is positive, there's going to be 2 real solutions. Okay, so now let's just figure out what the square root of 1 is. So I've got 9 plus or minus the square root of 1. Well, the square root of 1 is 1, all that over 20. Okay, so now let's do the x1 and the x2. So x1 is equal to 9 plus 1 over 20. And the other one, x2, is 9 minus 1 over 20. So that's where the 2 solutions will come in. So 9 plus 1 is 10. So x1 is equal to 10 over 20. I could reduce this to 1/2 if that's what you like. But you know what? If you do 10 divided by 20 in the calculator, you would also get 0.5. So I would accept either one of these. Okay? x2 is equal to 9 minus 1, which is 8 over 20. And I could reduce this by dividing the top and bottom by 4, thus getting me 2/5. Or if you want to figure out what that decimal is, that'd be 0.4. So either x is equal to, well, I suppose I could box this as well, but please make it a simplified fraction. So x is equal to 1/2 or 2/5. X is equal to 0.5 or 0.4. Either way, I want to see these unique solutions. Pick team decimal, pick team fraction. Either one works for me. Okay, moving on. Problem number 3. Oops. 3x squared minus 13x minus 56 equals 0. Same thing. I could factor. Well, I could have a really hard time figuring out what multiplies to 3 times negative 56. And that's a negative 13. I mean, I don't even know what 3 times negative 56 is off the top of my head. So you know what I can do? I can do the quadratic formula. It's the end-all, be-all. Does this have a solution or not for the quadratic trinomial? Okay, so my A is 3, my B is negative 13, and my C is negative 56. Let's find the x-intercepts of this quadratic trinomial. So the x-intercepts can be found by taking negative b, in this case, the b is negative 13, plus or minus the square root of negative 13 quantity squared, minus 4 times a times c, which is negative 56. All that over 2 times a. The a is 3. Let me darken that a little bit so you can see it. So now let's clean this up. Negative 13, well, that's just a positive 13. Okay? 13 plus or minus the square root of negative 13 quantity squared. Negative 13 times negative 13 is 169. And then I'm definitely going to need a calculator for this part. Clear, clear, clear. So I've got negative 4 times 3 times negative 56. So that's going to be positive 672. Yeah, I'm going to need a calculator. So all that over 2 times 3, which is 6. So now I've got 13, 6 on the bottom. And now I'm going to figure out what 169 plus 672 is. That'd be 841. Hopefully that is a perfect square. Well, either way, same old, same old. The discriminant is found. We know what the discriminant is. It's a positive number. So since b squared minus 4ac is positive, the quadratic trinomial has 2 real solutions. Okay? So now that the quadratic trinomial has 2 real solutions, let's figure out what is the square root of 841. 29. Ooh. So now we've got 13 plus or minus 29 over 6. Well, that explains the 2 real solutions part, because now we've got x1 is equal to 13 plus 29 over 6. Or x2, 13 minus 29 over 6. Let's do it. So now, 13 plus 29, well, if 10 plus 20 is 30, and 3 plus 9 is 12, so that'd be 42 over 6. So x1 is equal to 42 over 6. x1 is equal to 7. So one of the solutions is x equals 7. Let me just double check. Yep, I did it correctly. Let's take a look at the other one. 13 minus 29 would be negative 16. So x2 is equal to negative 16 over 6. Let me just reduce this really quick. Let me just divide the top and bottom by 2. So that's going to be negative 8/3. I think that's going to be a good call for me to leave this as a fraction, because if I did negative 16 divided by 6 or negative 8 divided by 3, it's the same result. I'm still going to get negative 2.6 repeating. So you could also write this as negative 2.6 6666666 repeating. So either one of these two for the second answer is great. So either x is equal to 7 or negative 8/3, x is equal to 7 or negative 2.6 repeating. Team fraction, team decimal, I don't really care. Just show me the unique 2 solutions. Okay? Okay. Moving on to problem number 4. 16x squared plus 24x plus 9. Once again, A is 16, B is 24, and C is 9. So now, let's plug them in. Negative B, the B is 24, plus or minus the square root of B squared, 24 squared, minus 4 times A, 16, times C, 9. All that over 2 times A, which is 16. So I'm definitely going to need a calculator for this, I'm not going to lie. So now we've got negative 24. Okay, nothing to clean up, just the negative number in front. plus or minus 24 squared. So let's figure out what 24 squared is. 24 squared is 576. Negative 4 times 16 times 9. Ooh, this is different. This is different. All that over 2 times 16, which is 32. Okay. So now we've got negative 24 plus or minus the square root of 0 over 32. And now this is interesting because since b squared minus 4ac is actually equal to 0, well, the square root of 0 is 0. If I do plus 0, in fact, let me just show it to you right here. If I do negative 24 plus or minus 0 over 32, if I split this up into two cases, negative 24 plus 0 is negative 24. Negative 24 minus 0 is still negative 24. There's no need to copy this down into x1 and x2. So what this tells me is that there's going to be only one real solution. Let me just put the focus on really quick. There we go. So because the discriminant is 0, there's only one real solution. So all I need to do is just write negative 24 over 32. And I could simplify this fraction. Let me see if it ends up as a nice decimal first. Negative 0.75. So in other words, I could reduce this by dividing the top and bottom. I could divide by 2, I could divide by 4, I could divide by 8. Let's make that easy. So that's going to be negative 3 over 4, and that's totally fine. Or x is equal to negative 0.75 if you did the division ahead of time. These are the same result. These are the same number. Okay, but the important thing is that there's only one real solution to get 16x squared plus 24x plus 9 is equal to 0, and that'd be negative 3/4, or negative 0.75, same number. Okay, 2 more problems. Let's go. 9x squared minus 41x minus 20 is equal to 0. So I could factor, you know what two numbers multiply to negative 180 and add to negative 41? You know, that's a good step. But you know what? Personally, I like the quadratic formula because if I'm going to take forever, I might as well determine what that discriminant tells me about the solution set. So specifically, A equals 9, B equals negative 41, and C is equal to negative 20. Okay. So now I've got B is equal to negative 41, so negative B, even though there's a negative in front, I'm going to put negative 41 plus or minus the square root of negative 41 quantity squared minus 4 times A, 9, times C, negative 20. All that over 2 times negative 9. Let me just make that, positive 9. I'll make that a positive 9. I put that in pen. Oh yeah, there we go, positive 9. No harm, no foul. I like that. So now we've got negative 41. Let's clean this up a little bit. Negative 41. Well, that's going to be a positive 41. And I'm definitely going to need a calculator for this part. So just to be clear, negative 41 in parentheses squared. So that's negative 41 times negative 41, which is positive 1,681. I did not know that. You learn something new every day. So now we've got 1,681. All right, now we're going to multiply negative 4 times 9 times negative 20. And that is positive 720, because two negatives form a positive, so that's positive 720. All that over 2 times 9, all right, that'd be 18. So 41 plus or minus whatever that is over 18. Now I'm going to add 1,681 plus 720. And I'm going to get 2401, 2,401. So now, okay, once again, we've got the discriminant. I like the discriminant because it's positive. So because b squared minus 4ac is positive, what that means is that there are two real solutions. So there's going to be an x1 and an x2. All right, so I'm going to get this part out of the way before I go onto the calculator. 41 plus or minus whatever the square root of 2401 is over 18. So let's do the square root of 2401. $49. Oh, I did not know that. Apparently 49 times 49 is 2,401. Use a calculator. It's okay. So now, let's split it up into two equations. Okay? x1 is equal to 41 plus 49 over 18. Okay? Alrighty. 41 plus 49 is 90. 90 over 18. 90 divided by 18, I think it's 5, but I'm just going to double check with the calculator because even I make mistakes. 90 divided by 18 is positive 5. So one of the solutions is x is equal to 5, or x2. So we did 41 plus 49 over 18. Let's do 41 minus 49 over 18. So that's going to be 41 minus 49. That'd be negative 8, if I'm not mistaken. 41 minus 49. That'd be negative 8 over 18. So x2. I suppose I could simplify this by dividing the top and bottom by 2. So that'd be negative 8 over 18, which would be negative 4/9. And I'm okay with that. Just leave it as a simplified fraction. However, if you really wanted to do this, negative 8 divided by 18 and see what the decimal is, negative 0.4 repeating. Please indicate that it is repeating by putting negative 0.4 with a hat on. It's the same result. Just to double check, you could do negative 4/9, and it's the same decimal as well. Okay. Team decimal, team fraction, it doesn't matter. They're the same. They're the same value. Okay. All right. Last problem. Can you believe this is the last video, guys? I'm so proud. All right. 6x squared plus 4x plus 9. Okay, so I saved this one for last. A equals 6, B equals 4, and C is equal to 9. Set it equal to 0. Let's plug in the quadratic formula. So we've got B equals 4 plus or minus the square root of 4 squared minus 4 times A, which is 6, times C, which is 9, all that over 2 times A, which is 6. So now, negative 4, that's just negative 4, plus or minus the square root of 4 squared, 4 times 4 is 16. All right, so I'm going to have the, and then, let me just get the easy part. 2 times 6 is 12. So now, negative 4 times 6 times 9. So that's going to be negative 216. Okay, so 16 minus 216. So now we've got negative 4. We've got 12 on the bottom. And then 16 minus 216, that's going to be negative 200. Hold on a minute. Let me actually try to figure out what the square root of negative 200 is. It's not a real answer. Oh, that makes sense because I take a look here this time. Hey, b squared minus 4ac is negative. So because I cannot take the square root of a negative number in the real number system, this is an impossible problem to solve in the real number system. So therefore, the solution is that there is no real solution. There's no real x-intercepts to this problem. Yes, there may be a problem where there is no real solution, and that's because the discriminant is negative. Okay? This has been a pleasure to teach you guys. Good luck. Please reach out if you have any questions, and I'll do my best to assist you. You have my permission to use this template for the exam. Have a good day. Stay safe. Happy summer. Bon voyage, whatever. I don't... stay safe, okay? I care about you guys.